All right, everybody, welcome back. This is our 7th episode in this AP exam review series, and today we will be finishing up derivatives with derivative applications, part 3. And something I want to just stress from last time, we did talk about in a previous lesson motion along a line, talking about position, velocity, and acceleration. And I really wanted to stress the importance of remembering that these concepts extend to all different types of applications, right? When we talk about position, this could just represent amount. We want to think of that as the same amount of water. It's on the same level. It's measured in some unit, right? Velocity, this would be just a rate of change, measured in units per whatever the time is. And then acceleration, that's just going to be acceleration across the board. And remember that the units are units per time squared. Acceleration is the rate of change of the rate of change, or whatever that problem is. How fast is the rate of water flow changing? All right, 3 topics today for derivative apps. We're going to start with, first thing will be to look at the mean value theorem. We've already looked at the intermediate value theorem, and I've mentioned the extreme value theorem. That's the one that just says a function has to have an absolute max and an absolute min. But the mean value theorem is probably the most important one for you to fully understand. So let f be a continuous and differentiable function on some interval. What is true, or what must be true if it is? Let's say we have 2 points, x equals a and x equals b. And I'm going to draw just a nice, smooth, continuous and differentiable curve from a to b. So what does it say? Mean value theorem says that the average rate of change, so the slope from a to b, must be at least at one point equal to the instantaneous rate of change. And that one point, we're going to call that c. So there's a point where the average rate of change, which if I draw that on the graph, would be the slope of the line secant through a and b, is equal to the instantaneous rate of change at some point c. So that would be the slope of the line tangent to the curve. It creates 2 parallel lines. This could look a lot of different ways in a problem. Some basic problems that we've seen, you can probably look back at our work from earlier this year where you have to solve for c, what the point is where that's happening. But one I want to stress in this video is, let's say you do have a continuous function and differentiable function f. Let's say I tell you that f of 4 is equal to 6 and f of 2 is equal to 2. Must there be a point on 2 to 4 such that f prime of c is equal to 2? Anytime you are asked to say that there has to be a value for the derivative at some point, that's going to be looking at the mean value theorem. And the way that we're going to solve this is by doing average rate of change. 6 minus 2 over 4 minus 2 is 4 over 2, which is 2. Because the average rate of change is equal to 2, yes, there must be a point where the instantaneous rate of change is equal to 2, and the justification would be by the mean value theorem. So that's a simple example, but one that I will hope will serve you well, especially on a free response style question. Okay, second topic, I want to look at optimization. And I want to look at optimization from the AP exam kind of standpoint. What does it look like on an AP exam? And optimization is simply just finding the max or min of a real life problem. That's the way I'm going to describe it. Find the maximum amount of water. Find the maximum upward velocity of this object, whatever it is, right? Find the max or min of some real life problem. You're going to do this the same way you would find the max or min of any function. First thing is you're going to find the equation. Maybe that equation, like I said, is just a velocity equation that you're trying to maximize. Maybe it's one of those problems where you have a rate going in versus a rate going out. And then the amount of the equation will be the integral of the rate in minus the integral of the rate out. We'll get to that in a later lesson in more detail. If you remember back in class, we did a lot of problems that involved two equations. We had to do a substitution, like these fence problems, maximize the area, whatever it is. Not typical on the AP exam, but maybe worth looking over. So find the equation. What do you do with that equation? Well, you take the derivative. You set it equal to 0, and you get the critical points, just like we always do. Once you know those critical points, you're going to use them to find the max and min. And for these problems, if you take the derivative of velocity, you get acceleration. So when acceleration is 0, that's a critical point for velocity. You took the derivative of this integral function, rate in minus rate out. The integrals would go away. You just have the rate in minus the rate out. So then what do? Well, we're going to run the candidate test. And remember, the candidate test is where we take your critical points and your endpoints into the original equation. And then finally, answer the problem. Does it want to know the time when the maximum occurs? Does it want to know the maximum amount of water? Just make sure you answer the problem with correct units to get all your points. And that's it. Make that, when you think about optimization, I feel like that really simplifies it and will help you focus on it on the AP exam. All right, last thing, and I saved the best for last. We all know what's coming. It's been mentioned in some previous videos, but it deserves its own mention now. L'Hopital's rule. Remember, L'Hopital's rule is used for evaluating limits that are of an indeterminate form. So if the limit as x approaches some value of f of x over g of x takes on an indeterminate form, 0 over 0 or infinity over infinity, or my BC guys will know there's a ton of these that we did. We'll need to look back at those. We don't have time for that right now, but look back at all those indeterminate forms. So most of them revolved around getting it back into one of these 2 forms. So if this happens, then we can take the derivative of the top and the derivative of the bottom and try again, try to plug in again. If you get an indeterminate form this time, you can do it again with the second derivative. Maybe you get a value this time. Maybe you get undefined. If you get 1 over 0, you're done. It's undefined. So just be careful when you use L'Hopital's rule. Be prepared for this to show up in a lot of different ways. Everybody loves L'Hopital's rule. Make sure when you see it on a free response that you show the indeterminate form and state that you're using L'Hopital's rule, and then do it. Have some fun with it and get excited if it shows up this year on the AP exam. Okay, guys, that's it for today. I'll see you guys back next time for integration, and we'll get going into some of my favorite work in the entire course. Have an awesome day. Good luck with the rest of your studying.